Yeah, children, today we are going to discuss 11th class chemistry, children. See here, 11th class chemistry. So, first lesson, chapter 1, and I'm going to discuss today 1 to 5 questions, children. Only 5 questions. First question. Okay, first question, calculate the molecular masses of methane, water, carbon dioxide. That's all. Molecular masses. So, carbon is 12, children. Hydrogen is 1 into 4. 12 plus 4, that is 60. Hydrogen is 1 into 2, 2 atoms are there, plus 60. So 18 U, atomic mass units. Okay. Carbon is 12, oxygen is 16, 16 to the 32, 44 atomic mass units. This is your first question. First question is over. Second question. Coming to the second question, they're asking, calculate the mass percent of different elements present in sodium sulphate. Formula of sodium sulphate is Na2 SO4. Each element percentage we have to find out. So first let us find out the molecular weight. So molecular weight of sodium is 23, 23 plus into 2. Sulfur is 32. Oxygen is 16, 16 for the 60, 16 into 4. Okay, so 46 plus 32 plus 64. 100, 132. Atomic mass units of 132 grams. Okay, so 132 grams. Approximately it will be 132 grams. Now, each element's percentage. 132 grams. Okay, 1 second, children. 64. No, it is 142. Not 132, 142. 142 grams of sodium sulfate has 46 grams of sodium. 100 grams of sodium sulfate will have how much amount of sodium sulfate? Sodium, to find out the percentage. Okay, so when you are finding the percentage, you have to do cross multiplication. When you do cross multiplication, 142 into this is equal to 46 into 100. So x is equal to 4600 by 142. Okay, so when you divide 4600 divided by 142, you'll get 32.3%, 32.39 percentage of sodium. Now let us find out in the same way percentage of oxygen. Same procedure. 142 grams of sodium sulfate will have 32 grams of oxygen. 100 grams of sodium will have how much? So same. So 142 into x is equal to 32 into 100. How much is that? X is equal to 3200 by 142. So children, so 3200 divided by 142 is how much? 22.5%. 22.5% of oxygen. No, sulfur. This is sulfur because 32 grams is sulfur. In the same way, so now let us find out oxygen also. 142, or else we can subtract also this both from 100, that also it is same. So 142 grams have 64 grams of oxygen. 100 grams will have how much? So 142 into x is equal to 64 into 100. So x is equal to 6400 by 142. So 6400 divided by 142 is 45.07%. This is percentage of oxygen, this is percentage of sulfur, this is percentage of sodium. So like this we are going to find out the percentages, individual percentages of a compound. Next, third question. Check the third question. So third question is like this. Determine the empirical formula of iron which has 69.9% of iron and 30.1% of oxygen. Empirical formula we have to find out. So what is the procedure we follow for empirical formula? First, divide individual percentages with their atomic weights. Atomic weight of iron is how much? 55.85 approximately. Okay, 55.85 approximately. They will give in the book. They will give in the question. You need not worry. And oxygen, we know it is 32. So when you find out, it will be around 1.25. You have to divide in their atomic weights or molecular weights, and this will be around 1.8 each. 1.8. Now, among this both, 1.25 is smaller, so divide both of them with 1.25. 1.25 by 1.25, 1.88 by 1.25. So this will come 1, and this will come around 1.23, 1.28, and this will come approximately 1.5. Okay, so iron is one part, oxygen is 1.5, but we can't take 1.5, isn't it? So multiply this with 2, this with 2, make it whole numbers. So this is 2, this is 3. So the formula of iron oxide is Fe2O3. So what is the procedure? First we will divide both the percentages with their molecular weights. You will get some ratios. Divide both of them with the simplest of both. Simplest of both is 1.25. Divide both of them. After dividing, you'll get here 1, here you'll get 1.5. You can't keep a decimal, so that way to make it a whole number. So you divide, multiply with 2, you'll get here 2, here 3. This is third question. Okay, empirical formulas you have to practice, student. If you practice, you'll understand. I hope you are able to understand. Now coming to the third question. Okay, so coming to the fourth question. Fourth question is, calculate the amount of carbon dioxide that could be produced from 1 mole of carbon. Children, when 1 mole of carbon is burned, when 1 mole, here also 1 mole, here also 1 mole you are getting. Okay, so this is 12 grams. 12 grams of carbon reacts with 32 grams of oxygen. By law of conservation of mass, you get 44 grams of carbon dioxide. Okay, so 12 grams is given 44 grams. So he's asking 1 mole of carbon produce how much? 1 mole means 12 grams. So 12 grams of carbon will produce 44 grams of carbon dioxide. That is easy. Directly from the equation you can say. Now, if suppose 1 mole burns in 16 grams, children, 12 grams is reacting with 32 grams. But if 12 grams is reacting with 16 grams, how much carbon dioxide you will get is asking. How much carbon dioxide you will get? 16 grams only it is reacting. Okay, so 32 grams is giving 44. 16 grams will give how much? Try to understand. 32 grams of oxygen is giving 44. 16 grams will give how much? Automatically 32 gives 44. Then 16 will give 22 grams of carbon dioxide. Second answer. Third answer. If 1 mole of 2 moles of carbon is burnt, children, 12 grams is reacting with 32 grams. Now 2 moles of carbon means 24 grams. 24 grams. You take 2 moles or 3 moles or 4 moles, but here he is saying 2 moles are reacting with 16 grams. He is saying 16 grams. Okay, so children, 12 can react with 32. Okay, so 24 can react with 64 normally. Try to understand, children. This is very, very important. Since here oxygen is the limiting reactant, 16 grams of oxygen will react with only 16 grams. See here, 12. We have 24 moles. Okay, 12 is needing 32 means 16 will require how much? Let us calculate. 12 into 16 is equal to 32 into x. This goes here. X is equal to 12 into 16 by 32. 6 grams only. Okay, 16 grams will react only with 6 grams. So 24 minus 6, 18 grams of carbon will go waste. 18 grams will go waste. Even though you are supplying 24, it reacts with 6 only, children. It will react with 6 only. It won't react with more than that. And last question, children. Last question. Calculate the mass of sodium acetate. Formula of sodium acetate CH3 COO in carbon is how much, children? 12. Hydrogen 3. Carbon 12. Oxygen 2 oxygens are there, 32, 16 plus 16. Sodium is 20. So sodium acetate whole atomic weight will become how much, children? Atomic weight of sodium acetate will become approximately 80. Now question is calculate the mass of sodium acetate required to make 0.375 molar in 500 ml of solution. What is the molarity formula we have, children? Molarity is equal to weight by molecular weight into 1000 by volume in ml. 0.375 is equal to weight is how much, children? We have to find out. Molecular weight is 82. 1000 by 500. 500 2s are 241s are. So 0.375 into 41 we should do. So how much you are getting approximately? You are getting 15.38 grams. 15.38 grams of sodium acetate is being like this is a formula I have to remember from Molar. Okay, children, I hope you understood everything. Remaining questions we will do in the next class. Okay, children. Anyone have any doubt?